Welcome in lecture series of electrical installation and practices. In the previous lecture, circuit breaker has been discussed. Now today, we are going to discuss instrument transformer, which is one of the important part of substation. It is used for extension of ranges. So as earlier it has been discussed that the general our instruments like voltmeter, ammeter, their ranges from 0 to suppose the voltage is there, voltmeter is there, so it is ranges with the 0 to maximum is 20 ampere lab instruments, and whereas voltmeter is 0 to 300 volt, or it may be a 600 volt. But in practice, in the substation, the voltage level is 132 kV, 400 kV. It may be a nowadays in the ultra high voltage, it is 765 kV even in India. And we are thinking towards the 1200 kV. Some of the say test line has been laid out. Now in this case, if you are not able to measure the high voltage, it is necessary to extend the range of existing voltmeter, ammeter and energy meter. So in this case, the current has been stepped down to the manageable level. Means suppose the current is 100 ampere, it may be HT current or LT current. It is stepped down up to the 5 ampere, or it may be the 1 ampere for the different application. So this step down the current to the manageable level is a 5 ampere. It is done with the help of current transformer. Now, if our secondary side of the current transformer is going to measure 5 ampere, it means that the actual current in the circuit is 100 ampere. Let the current is 2.5 ampere. It means that the multiplying factor is the ratio of 1000 by 5. So it is equal to the 50 ampere. So in this way, it is able to measure the high value of current with the help of current transformer. The ammeter and voltmeters are calibrated in terms of higher voltage, whereas the actual current it's flowing through the ammeter is only 2.5 ampere or 5 ampere maximum. Similarly, in case of the voltmeter is in case of the voltmeter, it is going to measure up to the 600 volt or 300 volt, but the voltage is 132 kV, 400 kV, 765 kV is there. So now this voltage is stepped down with the help of transformer, step down transformer, and the secondary of the step down transformer is connected with the voltmeter. So say here, this is the circuit, or this is the terminal where we are going to measure the power. Say it is 132 kV line is there, and somewhere it is. So in between this one, the transformer is connected, which has large number of turns in the primary side and less number of turns. So the voltage is going to step down, and here the voltmeter is connected. So this is the voltmeter, AC voltmeter is there, it is connected. So it is 100 kV by 110 volt. This is the standard voltage. So 110 volt across the secondary. So this less voltage or 110 voltage is manageable. We can measure with the help of our ordinary voltmeters, or the protective devices are connected on the secondary side of voltmeter. Similarly, in case of current, the current has less number of turns in the primary side, whereas there is a large number of turns in the secondary side, and here volt ammeter is connected. So here it is ammeter is connected. It is say 100 by 100 ampere in the load circuit. This is the load circuit, and whereas the secondary is 1 ampere or it is a 5 ampere. So these are the instruments. Instrument transformers are there, current transformer and potential transformer, which is used to step down the voltage for the measurement purpose, for the protection purpose in the substation. So this is current transformer. Because the current transformer is connected with the load, it is connected in series. So this is incoming terminal, this is outgoing terminal, and here This is the P1, P2, and in this box we have a terminal is secondary S1 and S2, whereas this is the 5 ampere. So it is outdoor type. So outdoor type, this is the insulators. Outdoor type insulators are there. This is outdoor type potential. This is also the current transformer. So this is incoming terminal, this is outgoing terminal, and the secondary terminals are connected from the box. So this is CTs are there. So there are different type of CTs. This is 132 kV CTs. It is again 132 kV CTs. These are the, this is CT bank. All three terminals or three phases are there included. Now there are some indoor type of CTs are there. So it is used for the cubical meters or say indoor applications. So this is incoming terminal, this is outgoing terminal, and here the secondary terminals are visible. Say this is the secondary terminals are there. This is the secondary terminals are there, whereas it is the primary terminals. So this is indoor type, and HT type of CTs are there. Now this is the potential transformer to measure the voltage with the help of potential transformer. So it is say 400 kV PTs are there. This is 132 kV, this is 132 kV. It has only one terminal, it is connected, and whereas the second terminal is connected to the ground, so the neutral one. So this is the, so it is quite clear in case of the substation. If the term, if there are two terminals are there, it means that it is a CT, and if there is only one terminal, it is a PT. So see here in this diagram, this is the substation layout. Substation diagrams are there at actual. So it has only one terminal. So this is have only one terminal. This is one terminal. So this is the PT, or it is constant voltage transformer. It is a PTs are there. This is PT, potential transformer, or constant voltage transformers are there. The secondary terminals, it's connected to the ground, whereas these are the CTs. CTs has two terminal. This is incoming terminal, it is outgoing terminal, and the secondary two terminal S1 and S2 is connected for the control purpose, for the measurement purpose, energy measurement, power protection, and so on. So this is the actual installation of CT and PT. It has indoor type, it has a SF6, it may be a dry CTs are also available. These are CTs and PTs are oil filled for the insulation, to increase the insulation level as well as the cooling purposes. Now second is the substation earthing, which is very much important. Earthing is, there are two type of earthing. One we can say that it is the say neutral earthing, and second is the say body earthing. So neutral earthing is provided for the transformer neutral, for the generator neutral, and so on. Because in case of generating plant, the generator is connected in the form of star. So this is a star connected generators are there. And in case of the neutral, it is connected to the ground. It may be connected with the inductor or resistance for the different point of view, for the protection point of view. Whereas the neutral body earthing, which is connected to the metallic part, non-current carrying metallic parts are there. For say, for example, it is the structure. Say it is simple double pole structure which we see in the our colonies or somewhere. It is a distribution transformer. The neutral of the transformer is connected to the ground. There are two neutrals are should be there for the neutral, and two neutral for the body earthing. That is a non-current carrying metallic parts are there. So earthing is done with the help of copper or aluminum, or it may be the CI plate. It has having different standard size. It may be a 300 by 300 by 5 mm. This is the size. It may be a 600 by 600 plate side. It may be a 6 or it may be a 10 mm. So it is buried in 3 to 4 feet, and it is filled with the coal, salt. Generally we are using earlier. This coal is used, salt is used to pick up or say uh, hold the moisture level, so that the resistance of the earthing pit should be small. And this is one pipe is connected. It is a perforated pipes are there to pour the water in the dry season, and it is connected to the earthing plate. So these are the one plate type of earthings are there. So second is the pipe earthing, or one copper rod earthings are there. One bore is carried out with the 3 feet, it may be a 6 feet are there, and the copper bar is connected. And this is one type of, it may be increased by increasing the different part by extending the length for the different applications. Say it is a 4 feet are there, this is 4 feet, so it is a 8 feet. So it is used for the different applications. If the substation size and the layout is much more, so we can bury it up to the 10 feet also. So this is conditioning salts is there, it is filled with this one. So it is a ready-made earthing rods are available, and the size is 2.2 inch there, the pipe size are there. So it is generally nowadays you are looking toward the uh, solar installation, because it takes less space for the doing the earthing pit. In case of the plate earthing, the size of excavated trench is very large, it may be a 3 feet by 3 feet, and whereas it is 1 feet widths are there. So it is most nowadays most common in application. It requires less space. Generally, it is used for the PV solar installation, but in case of substation earlier, we are using plate type earthing and pipe type earthing also. So this is the actual uh, earthings are there. This is also called as a earthing electrodes for the chemical earthing peoples are there calling. This is the length is around 10 feet. This is the 10 feet lengths are there. And if for installation of this such type of earthing, we have to do the boring, borewell, like say we have to do the excavation. And once the borewell type excavation is carried out, we will insert this earthing rod, and we will fill rest of the place with the some chemical material. So it will give the better result, and space required for the earthing should is also required will be smaller. So this is more practice nowadays. So there are different type of earthing rods are there. This is used for the connection. It is a copper earthing, and for the different application, threadeds are there to increase the length of copper earth electrodes. So these are the single ground electrodes are there. These are the chemical earthings nowadays we are using for the different applications. So say this is one typical layout of grid connected solar PV system. So there are different earthings are there. This is the DC earthings. It is used to connect the DC distribution box. So DC earthings are there. It is the AC earthing where the AC inverters are there, or AC DBs are there. It is connected to the ground. So this is one earthing is there. One more earthing is provided for the structure. So whatever the metallic structures are there for the installation of PV modules, and it is connected. So this is the body earthing. We can say that this is the DC earthing, this is DC DB earthing, this is AC DB earthings are there. Now for the substation, say this is the substation, it is fencing. Fencing also they're connected, because in the fencing electrostatic charges is going to develop, or induction charges are going to develop. So it is necessary to do the fencing earthing, say metallic part earthing. So it is non-conducting metallic part, this is non-conducting metallic parts are there. It is connected to the ground. So it is called as a ground earthing. Whereas the transformer earthing is used, two earthings are used for the transformer. So transformer neutral earthing also there, transformer body earthings are there, and rest of this CTPT earthing also carried out. So these are the typical layout of one single substations are there. And the earthing resistance is going to measure with the help of earth resistors. It is analog type. Nowadays digital earthings are there, digital meters also available. So for that purpose, these two extra rods are buried into the at a different distance, 10 feet distance are there. And this is the earthing pit under test. This is the earthing pit which we want to measure the resistance of earthing pit, whereas these two are the some two extra electrodes are there. So potential spikes are there. This is current spikes are there. It is connected. So there are three terminals. This is for the earthing, this is for the current, this is for the potential spike. And by connecting this spike, it may be hand type driven or it may be some digital. So the resistance should be less than 1 ohm for the neutral earthing, and for 3 to 4 say ohm, it is used for the footing earthings or body earthing. If the resistance goes more than 5 and 10 ohm, it means that the earthing does not proper. Either we have to re-excavate or we have to charge. In the dry season, it is necessary to pour the water in the earthing to provide give the proper results. So thank you. This is for the earthing and earthing layout.